We are trying to answer this question. Unfortunately, this question is left unanswered as far as I can read. There is no need to install other software or VLAN configuration. Adding a route to a container is halfway to the goal. Please don't get me wrong, I'm not criticizing. I just want to say in 2022, we have a better and easier option to solve this problem. Please have a read this post first and try to solve the question. This is a basic yet excellent material on routing and packet filtering. By completing this challenge, you can solve any similar problems in the real world. It doesn't matter if you are troubleshooting the state-of-the-art cloud network or 10-year-old legacy network problems. I'm not sure if I've reproduced the environment perfectly, as the questioner didn't provide a detailed setup. So let's think that we run the container with Docker default configuration. Precisely speaking, we will run Alpine by the simple command docker run Alpine, then ping Alpine from Kali. If we can get the reply, we are the winners. However, I'd recommend digging deeper by analyzing the debug logs. Okay, let me show a network diagram for visual understanding. This is the simplified network diagram. K stands for Kali Linux, U Ubuntu, and D Alpine. By the way, you don't need to follow my setup. The one thing I should note here is that I've prepared separate instances like this. This is for reproducing the environment in the question. Let's write down what we need to achieve the goal. We want to ping from K to D and get a reply. Does the publish option help? I might be making a stupid question, but I get the same kind of question once a year. Does icmp use ports? No. Why? Because the layer is different. Ports are for transport layer protocols, not for network layer protocols. So we will not use -p option. What does U do in this network? U connects different networks. Router. What do you need to route the traffic? Routing information and IP forwarding. In this case, V4. However, someone said on the past that even if she added the proper routes to each host, she couldn't get to D. So we may have to think of U as a firewall. The quick way to check out the firewall policy existence: compare the results when pinging from K to D and D to K. Did you remember that I mentioned zone defense at the beginning of this course? Traditional firewalls have loose control over internal to external traffic. Firstly, let's ping from U to D. Obviously, we can do that, but you know, this is a practice, so we don't have any UD routing filtering issues. Then let's check out from D to K. No problem. How about K to D? Well, yeah, I think we reproduced the problem. The strange thing is that we don't see any icmp to D on U. The traffic didn't hit the router in my environment, so I think I need to fix the routing configuration on K first. I have to mention here that please use Linux as a firewall U. If you are using Windows as U, things might be much more complicated. We couldn't spot icmp traffic to D on U, so K's routing configuration should be wrong. We pinged 172.170.2, so the packet should be routed to 172.170.0 network. Yeah, we've found the problem. The outgoing interface is Docker 0. That means that packets going to 172.170.2 got lost internally. The important thing is to visualize the behavior like this. If you face similar issues, get a pen and paper and write down what you have confirmed only, not imagined or assumed. Now let's see if we can observe the packets. Great. So what can you say here? We have now routing mistakes. The intermediate device and the destination are up and running. Ping from the opposite direction succeeded. Then time to check out filtering. Have you ever configured iptables? This is a packet filtering program generally called a stateful firewall. I think almost all the proprietary NGFW products are based on this. So once you get familiarized with iptables, it would be pretty easy to understand commercial NGFWs like Firepower by Cisco Systems, FortiGate by Fortinet, PA Series by Palo Alto Networks. I believe many of them are now armed with modern IPS, threat prevention system with AI flavor. And when it comes to digest the configuration, the vital points to keep in mind are that we have to always make clear from SRC to DST, protocol, action, deny or permit. Let's read the configuration with sudo iptables-s. A few lines of configurations. I know this is really hard to understand if this is the first time. Now, in our case, focus only forward lines. J means actions. We have 3 typical actions: accept, drop, and return, meaning allow, deny, pass. Other options like Docker user mean the filtering process jumps to the line. And -I means incoming interface, -O outgoing interface. Let's verbalize a line. -O Docker 0 means choose a Docker container. -M contract connection state check. -C state part means returning traffic. -J accept means allow. I'm putting everything into a sentence. And traffic from anywhere to the Docker container that was already marked OK by firewall protections will be allowed to pass. For example, imagine that we ping the Docker container to an external host. The container sends an icmp echo request to the external host. Then the host will send a reply to the Docker. The icmp echo reply will go through this rule and be allowed to pass because the reply doesn't originate from the external host. It's related with the echo request. And the kernel sees who starts the communication and who terminates it. That's called stateful. Sudo iptables LVN will show the working firewall rules. Keep focusing on forward. Policy drop means there is an implicit deny in this portion. If packets don't match the rules, they will be discarded. In the right corner, we can see counters for rules. If packets match the rules, the counters will increment. That said, we are not that interested in the exact numbers, right? So let's use these as indicators. When packets hit the rules, the counters will tick. We want to keep watching the counters. In that case, we can use the watch command with the option. This time, we will keep pinging from K to see which policies are reacting. We notice that policy drop is increasing. This means that icmp packets are dropped by implicit deny. Let's find out which policy is hit by the packets. Docker user. This policy does nothing but return, so we are going to the next policy. Docker isolation stage 1 has 2 rules, but the counter at return is blinking, so we'll check the next one. Accept is skipped because packets are incoming ones. ICMP requests are not considered as related or established. And so we go to Docker. Docker does nothing. it just sits there. To accept will not match any packets because the incoming interface is specified as Docker 0. Finally, the packets are dropped by the policy default action. Docker official document explains what we should do. We have to add a policy to Docker user to allow icmp traffic. I've explained all the options, so you should now understand the meaning of this rule. Check out from to protocol action. Yes, we can now observe that the different counters are increasing. We've allowed incoming icmp at Docker user, so other counters are blinking because of the returning packets. So the output shows that the icmp requests reached this container and the container replies. I think we can now pass the detailed steps to Stack Overflow. I'm enabling iptables tracelog for debugging. Depending on the OS you are using, the commands might be different. Please send DM or past questions with detailed steps if you are stuck. Our syslog.conf instructs that the default logging config is here. Please make sure to take a snapshot of the VM if you are not Linux proficient. It's easier to take a snapshot than to make a config backup when it comes to fixing strange errors. In my environment, the debug logs are written to var log curl.log. I'm not that interested in the curl log so far, so I'll clean up the log like this. I'm not sure if you've done the same procedure or you were just watching this video, but let's check out the log. Are you familiar with the manual log analysis? Seriously, it's a daunting task. So let me clean up the log for you. Well, the packet was finally dropped by trace filter forward policy 7. What does this mean? Anyway, let's follow the fail log, then you can follow any other logs. Looks better. So there are the excerpts from the collected log. The process starts from the top and goes down to the bottom. The first line says that the packet hit rule 1 Docker user. Docker user has only returned, so the packet went to the next rule. The log says next was rule 2 in the forward. So that should be Docker isolation stage 1. Docker isolation stage 1 has 2 rules, but the first one is for outgoing packets, so return. Okay, skip the 3. Remember that this is for already allowed packets. So rule 4 is Docker. The guy does nothing in my environment. The packet didn't match number 5 and 6. Incoming interface is different. Finally, the log says that the packet hit rule 7, which is not displayed. But it exists. That's why I said implicit deny. You should know implicit deny if you've got CCNA, right? Thanks for watching. Let's play with icmp tunneling in the next section. Remember, in any filtering program, we have to meticulously check sender, destination, protocol, action, and the rule order. Also, find a way to correct verbose logs in any challenging situations. Adversaries are highly likely jamming the logs, like obfuscating sender IP addresses. But even in that case, you will still be able to find suspicious traffic patterns.